Making the blind see. Artificial eyes introduction for centuries. Blindness has been considered one of humanity's greatest challenges. The loss of sight affects millions of people worldwide, limiting their ability to navigate the world independently. However, modern science and technology are bringing us closer to a remarkable goal: creating artificial eyes that can restore vision to the blind. These revolutionary devices offer hope to those who have lost their sight and represent one of the most exciting frontiers in medical technology. Understanding blindness. Blindness can occur for many different reasons. Some people are born without sight due to genetic conditions, while others lose their vision later in life due to diseases like diabetes, glaucoma, or macular degeneration. Eye injuries from accidents can also cause blindness.
Ow.
The eye is a complex organ that works like a camera, capturing light and converting it into electrical signals that the brain interprets as images. When any part of this system fails, vision can be lost. Types of artificial eyes. Prosthetic eyes. The most common type of artificial eye is actually a prosthetic eye, which is primarily cosmetic. These are custom-made to match the appearance of a person's remaining eye, but they don't restore vision. While they help people feel more confident about their appearance, they don't solve the fundamental problem of blindness. Electronic implants. More exciting are electronic devices that can actually restore some vision. These work by bypassing damaged parts of the eye and sending electrical signals directly to the brain or optic nerve. The most successful example is the retinal implant, which helps people whose retinas, the light-sensitive tissue at the back of the eye, are damaged, but whose optic nerves still function. Bionic eyes. Bionic eyes are sophisticated devices that combine cameras, computer processors, and implants. A tiny camera captures images. A computer processes them. And electrodes stimulate the remaining healthy parts of the visual system. The most famous example is the Argus to retinal prosthesis, which has helped hundreds of people regain limited vision. How artificial eyes work? Modern artificial vision systems typically work in several steps. First, a small camera mounted on glasses or implanted in the eye captures images of the surrounding environment. This visual information is then processed by a computer that converts it into electrical signals. These signals are sent to electrodes that stimulate either the retina, the optic nerve, or even the visual cortex of the brain directly. The brain learns to interpret these artificial signals as vision, though it's quite different from natural sight. Users often see patterns of light and dark spots rather than clear images. But with practice, they can learn to navigate their environment and even read large text. Current achievements. Today's artificial eyes have achieved remarkable success stories. Some users can distinguish between light and dark, recognize shapes, and even read large letters. People who are completely blind can now walk independently, find doorways, and locate objects. While the vision isn't perfect, these achievements represent incredible progress from total blindness. The technology continues to improve rapidly. Newer devices provide higher resolution images, and researchers are developing better ways to interface with the brain's visual processing systems. Challenges and limitations. Despite these advances, significant challenges remain. Current artificial eyes provide very limited vision compared to natural sight. The resolution is low, colors are difficult to distinguish, and the field of view is narrow. The surgery required to implant these devices is complex and carries risks. Cost is another major barrier. These devices are extremely expensive, making them inaccessible to many people who could benefit from them. Additionally, not everyone is a candidate for artificial eyes. As the technology requires certain parts of the visual system to still be functioning, the future of artificial vision. The future looks promising for artificial vision technology. Researchers are working on devices with higher resolution, better color perception, and more natural vision. Some scientists are exploring the possibility of connecting artificial eyes directly to the brain's visual cortex, potentially helping people with damaged optic nerves. Advances in materials science, computer processing, and our understanding of the brain are all contributing to better artificial eyes. Some researchers predict that within the next few decades, artificial eyes might provide vision that's nearly as good as natural sight? Impact on society. Artificial eyes don't just help individuals. They have the potential to transform society. When blind people can see again, they can participate more fully in work, education, and social activities. This technology could reduce the economic burden of blindness and improve the quality of life for millions of people worldwide. Conclusion: the development of artificial eyes represents one of humanity's greatest technological achievements. We haven't yet created perfect artificial vision. The progress made so far is remarkable. These devices are already changing lives, helping people who were once blind to see light, recognize faces, and navigate their world independently. As technology continues to advance, the dream of fully restoring sight to the blind becomes increasingly realistic. The artificial eyes of today are just the beginning of what promises to be a revolutionary transformation in how we treat blindness. Through continued research and development, we are moving closer to a world where no one has to live in darkness.